rectangular storage area is built against an existing wall. So fencing is needed for only 3 sides. You have 120 meters of fencing available. Let x be the width perpendicular to the wall and y be the length parallel to the wall. Find the dimensions x and y that maximize the enclosed area. Then determine the maximum possible area. So go ahead and pause this, see if you can draw a picture, do as much as you can until you decide that you can, and then we can go over it together. So just go ahead and give it a pause. All right, so I'm assuming that you want to check your work, or maybe you got stuck. That is fine. First, we'll start by drawing a picture. So this is my wall right here, the lines, and y is perpendicular, or sorry, y is parallel, x is perpendicular. So first what we need to do, we're going to have our equation right here in terms of x and y for the perimeter, which is equal to 120. So that would just be 2x plus y, because we don't need fencing for where the wall is at, right? So 120 meters, 2x plus y. We're going to solve for y. I like to put it on the left side, but that is just a personal preference type of thing. So now what we need to do is make an equation for the area in terms of x and y, which is very simple. We just have x times y. And now we just want it in terms of x. So what we're going to do is we're going to substitute this, right, into where the y is at. Easy enough. And then we'll just make it calculus friendly, so to speak. And the key to this now is to find the critical point. So the critical point will tell us what the maximum area is, and in order to find the critical point, we have to set the left side here equal to 0. Actually, sorry, you gotta take the derivative first. Getting ahead of myself. So ax equal to 120 minus 4x. Set that equal to 0. And so x is equal to 30. Right, so we have this one. Let's put the units in too, right? And how can I draw a nice rectangle? We're just gonna, there we go. Nice clean rectangle. And now we need to solve for y. We have y is equal to 120 minus 2 times 30. And so we get y is equal to 60. All right, easy enough. But how do we know that this is a maximum and not just a minimum? You know what I mean? So what we do for that is we do the second derivative test. We get an extra page here. Second derivative test. And 120 goes to 0. 4x becomes negative 4. And then we know that because this is less than 0, that the second derivative is less than 0, this is a maximum.